Heads up, this is the CPU, the brain of the computer. The metal lid on top is the integrated heat spreader. It protects the chip and helps with cooling. Underneath that small metal package is the actual core. The core sits on a substrate with thousands of contacts that link to the motherboard, handling all communication. A CPU can have multiple cores, and they do all the computing and data processing. Generally speaking, newer core types perform better than older ones. Inside a CPU is a super complex structure. We'll cover that later. Now let's look at the motherboard. The motherboard is a large printed circuit board with tens of thousands of tiny wires, plus soldered microchips, slots, ports, interfaces, and connectors. More on the motherboard in our next video. When the CPU is running, it uses as much power as about 16 LED bulbs, so it generates a lot of heat. That heat must be removed with a cooler. Here's a water cooling setup. The water block has a pump that circulates coolant through tubes to a radiator. The radiator's fins and fans then blow the heat away. The cooled liquid keeps looping. Water cooling works better than air cooling, but it's more expensive, more complex, and can leak. This is the power supply. It powers the whole computer. Components inside filter the incoming voltage and output different levels for each part. For example, an SSD only needs 5 watts, but a graphics card can need hundreds of watts. Let's crack open the GPU. We see a long circuit board. In the middle is the GPU chip. Around it are the blue VRAM chips. The yellow parts are voltage regulator modules. Above the board, there are heat sinks and fans for cooling. On the side of the card are HDMI and DP ports, a PCIe connector, and power plugs. Next up, memory, SSDs, and hard drives. Each memory chip contains an integrated circuit with 32 banks. Each bank has 8,192 columns and 65,536 rows. It temporarily stores data using capacitors and transistors. Those form DRAM cells. Data access is crazy fast, 10 to 15 nanoseconds. Solid-state drives store data permanently using 3D NAND arrays. These arrays can be 100 to 200 layers tall, 32,000 to 64,000 columns wide, and 32,000 to 64,000 rows deep. A single SSD chip stacks multiple 3D arrays, so a tiny chip can hold terabytes of data. Because the 3D structure is extremely complex, SSD data access takes about 50 microseconds, roughly 3,000 times slower than RAM. SSDs come in M2 and SATA types. M2 is faster and smaller, our top choice for building a PC. Hard disk drives have multiple spinning platters and a motor that spins thousands of RPM. A read-write head flies over the platters to access data. This mechanical design makes them far slower than SSDs. But HDDs are cheaper and can store data for longer. Even if they break, you might still recover your precious data. That's every component in a computer. Actually, pretty simple. Next video will show you motherboard ports and teach you how to build a PC. Hit that follow button and see you next time.